morning, everyone. This is my first Capstone project, and for this project, I will go over the electric vehicle population that was registered by the Washington State Department. So the goals and the analysis of this project is for me to delve into the various aspects of the electric vehicle market, including segmentation by make, model, and EV type, analysis of sales trends over model years, and examination of the distribution of the electric vehicle models across different regions. So the first thing for me was to download my data from Kaggle and import the necessary libraries such as pandas in order to read the data from the CSV file that I've downloaded and to be able to display it such as so. And after that, I've used the info method in order to see how many entries and columns there are in my data frame. And from this, I've found that there's more than 150,000 entries and more than 17 columns. But for the goals or the analysis of this project, I will only use 7 columns, which are make, model, electric vehicle type, model year, city, state, and county. So after I've imported and displayed the data, which I've saved into a data frame called EV data, I will now prepare the data that I will use for this project. I've stated that I'm only going to use 7 columns, and in those 7 columns, we know that from getting the info method above that the columns county and city are missing some values. To tackle this, I decided to drop the entire row where there are missing values for the 2 columns. I've used the drop NA method to do this, and using the info method, we can see that after I've dropped the NA values for these 2 columns, we can see that the 7 columns that I have, county, city, state, model year, make, model, electric vehicle, all have the same number of non-null values in their entries. And since there's no longer null values present in the data or in the columns that I need, I will therefore just drop the remaining columns that I no longer need for my analysis and updated my data frame. So for my new data frame, EV data, I only have the data from the columns city, state, county, make, model, model year, and electric vehicle type. So now, in order for me to visualize and analyze my data frame, I have to import the necessary modules from the Boogie library, which includes the figure and show in order for me to create my plot and to display it. And I've also imported the hover tool to add interactive hover tool tips to my plots, and the math module as well to provide mathematical functions. Now, the first thing in my analysis is that I want to segment the electric vehicle market by make, model, and electric vehicle type. And in order for me to do this, I will use the group method. So, first visualization was for me to group my data by the make column, in which I gather all rows with the same make value together. And for each group or for each unique make, it will then calculate the size of the group or the number of rows in each group, and after grouping and calculating the size, it will reset the index of the resulting data frame. And then I've also then renamed this index, which contains the size of each group to count. I've also calculated the percentage of each make group in my data frame EV make by using the sum function to calculate the total number of electric vehicles across all makes and storing this value as make total. I've then calculated the percentage of each vehicles for each make by dividing the count of electric vehicles for each make by the total count of electric vehicles, then multiply by 100 to get the percentage. This calculation is applied to each row of the data frame EV make, and the results are stored in a new column called percentage. I then created a column data source object name source using my data frame EV make to efficiently store and manage data for plotting. Next, I have to create a vertical bar plot using Loki to visualize the total number of electric vehicles by make. In order to do this, I've used the figure function to create a new figure object for the plot with the specified title, x-axis label, y-axis label, height and width, and that the x-axis range is set to the unique values in the make column of our data frame EV make. I've also set the orientation of the x-axis labels to be tilted at a 45-degree angle for better readability and remove the grid lines along the x-axis. I've then used the V-bar function to create vertical bars for each make with the height of each bar representing the count of electric vehicles and the x coordinates determined by the make column. The data source for the plot is provided by the column data source object source which I've created earlier. I've also added a hover tool to the plot, which displays a tooltip showing the percentage of each make when the mouse hovers over a bar. Using the show function, here is the visualization of our data frame. We can see that if we hover over our plot, we can see the percentage of each electric vehicle make. We can see that Tesla has the highest percentage of electric vehicle by makes. Now I have to do the same process again, but for the electric vehicle type, and basically just the same process by make, except I have to group my EV data by the electric vehicle type, use the size function to count how many rows there are for each type, and name this column as count, and use the reset index function to make this count column our new index for our new data frame EV type. And here is the new plot by the electric vehicle type, in which if we hover over our plot, we can see that the battery electric vehicle type consists of approximately 78% of the registered electric vehicles in the Washington state. Now, I want to visualize the data frame by the models or by the specific models of each brand of electric vehicles there are in my data frame. And since there are 37 electrical vehicle makes in the data frame, I have to make a for loop that will see which brands have more than one type of electric vehicle to graph. Those brands that is not part of the visualization is because that brand or that make has only one type of electric vehicle. So first, I initialized an empty list called brands that will store the brands that or makes that have more than one type of electric vehicle. I then have to make or use the group by function again to store or group the data by make. I have to do this again because the group by make function that I made earlier called EV make does not contain information about the models for each brand. However, I did use EV make data frame in my for loop, which will iterate over each brand in the make column of my EV make data frame. And in this for loop, it will check each brand the number of unique models associated with that brand and see if it is greater than 1. If it is, it appends the brand to the brands list, and if it not, then it just skips the brand. I've also initialized another empty list called plots to store the individual figure objects for each brand. In order for me to create a plot for each specific brand, I have to create another for loop which will iterate over each brand in the brands list. In order to get the corresponding group of data for each brand, I have to use the get group function and then extract the unique models associated with that brand. I then created a new figure called model fig for the brand with a title set to the brand name and labels for the x-axis and y-axis. Using the value count function, I calculated the counts of each model associated with the brand and created a data dictionary called data with model and count keys. Using the vbar function, I created vertical bars for each model with the count as the height, and then append the model fig or the figure that I created to the plots list. Again, I did this for every brand there is in the brands list. I then used the grid plot function to create a grid layout called grid with width and height, and use the show function to display the grid layout. Here is the visualization of the models for each brand or make in our data frame. We can see in this visualization which model for each brand is the most registered models in the state. I've also created a bar graph of a specific make, model, and electric vehicle type side by side. In order for me to do this, I used the group function again to group my EV data frame by make, model, and electric vehicle type, and use the size function to count how many rows of a specific make, model, and electric vehicle type there is in my data frame, and called this column count and reset it as my index, and created a data frame called segmented market. I then concatenated the make, model, and electric vehicle type columns into a new column called region using a lambda function, and created a column data source object from the segmented market data frame. I then created a figure called segment fig for the visualization, specifying the Y range, height, width, title, and X axis labels. Using the hbar function, I created horizontal bars for each combination of make, model, and electric vehicle type with the region as the y-coordinate, count as the right coordinate, and the source as the data source. Then I set the color of the bars to sky blue. Here is the resulting visualization of my segmented market. We can see from this visualization which specific make, model, and electric vehicle type for each brand is registered mostly in the Washington state. The next thing for me to analyze is the trend in the electric vehicle sales by model year. To do this, I first have to group the data by the model year using the group by function, and then count the number of vehicles for each model year. To make visualization easier, I first have to change model year from an integer to a string. I did this by using the apply function on the model year in the model year column of our EV data frame. And by using the info function, we can see that after we change our model year, we can see that it is now an object D-type. Now, by using the group by function, I can group our EV data by the model year and save this on a variable called EV year. Next, in order to count the number of vehicles there is per model year, we will take the size of each group in the EV year group by object. This counts the number of rows in each group, which corresponds to the number of electric vehicles registered for each model year. I then stored the result in a series containing the count of vehicles for each model year called sales by model year. Just like how I plotted the make, model, and electric vehicle type earlier, I basically used the same code, and then by doing that, here is a visualization of the electric vehicle sales per or by model year. We can see that in this plot, 2023 has the highest number of registered electric vehicles. Another way to use this visualization or this plot is that this plot allows users to easily identify the years with higher or lower sales volumes and understand the distribution of sales across different time periods. I have also created a line chart to see the trend better using the same data as above. For my last analysis, I will utilize the columns such as county, city, and state to examine the distribution of electric vehicle models across different regions. To do this, I will group data by the desired geographical level, which is the county, city, and state, and then I will count the number of vehicles for each combination of region and electric vehicle model. To start this, I will use the group by function to group the data frame EV data by the columns county, city, state, and model, and that for each unique combination of county, city, state, and model, it then will count the number of vehicles. It will then reset the index of the resulting data frame and assigns a new name count to the column containing the counts. Then I save this in a variable called vehicles by region. I will then create a list of unique regions by extracting unique combinations of county, city, and state from the data frame created above. The next thing I did was import the palette called Viridis in order to assign a specific color to a specific region that I've created. But since Viridis can only return colors up to the base palette's length, which is 256, I have to first determine the number of unique regions there is in the dataset, and then define the desired length of the palette is the number of colors to generate from the Viridis palette. Since the number of unique regions may be larger than the desired palette length, I calculated how many times I need to repeat the Viridis palette to cover all the regions. After calculating the number of times the palette needs to be repeated, I then generated a truncated version of the Viridis palette with the desired length. Then, I repeat this truncated palette as many times as necessary to cover all the regions. Finally, I use the truncated palette to assign color to regions. This ensures that I have enough colors to cover all the regions in the dataset without encountering any errors. In order to visualize the distribution, I have to import the matplotlib because the notebook had a hard time displaying the boogie plot for this figure. To do this, or to visualize the distribution of electric vehicle models across different regions, I first had to create a new figure. Then iterate or create a for loop that will iterate over each unique region in the data frame vehicles by region, along with the corresponding group data. Using the bar function, which plots a bar chart for each region, where the x-axis represents the electric vehicle models, the y-axis represents the number of vehicles, and each bar corresponds to a specific model. I then gave labels to my x-axis called the electric vehicle model and to my y-axis called the number of vehicles, and then gave the title distribution of electric vehicle models across different regions for my plot. Then using the show function, I then displayed the plot. Here is the resulting visualization. As you can see, I have to scroll up because I ended up having more than 9,000 numbers of unique regions. And I also got a user warning where it's telling me that the bottom and top margins cannot be made large enough to accommodate all axis decorations. And here is the actual plot otherwise. I'm still working on it. It's not the very best, but this is the most I can do at the moment. This concludes my analysis for my first Capstone project. Thank you.